Hello everyone, hope you are doing well. I'm Reza, founder of the optimizationcity.com. In this film, we answer this question: what is the minimum cost flow problem? Let's move on.
In the minimum cost flow problem, a general form of the network problem, we want to distribute the same type of product from the factory to the sale market efficiently. We know the quantity of the products produced at each factory and the required quantity at each destination is known and is certain. Instead of sending product directly to the destination, we can send them to distribution center through the intermediate point instead of directly. So here in this network, you can see that the node 2 and node 3 is the intermediate point, and node 1 is the origin, and node 4 and 5 is a destination. However, there are limits on how much can be transported on each transportation line. So this is the transportation line, and this number, which is 4, is the capacity of this line. The objective is to minimize the cost of transportation product while meeting the demand. So let's look at the simple example of the minimum cost flow problem using the diagram. Here, the nodes are shown are number circle. So node 1 is a 1 in the circle. And the arc are represented by arrow. So this is the arc from 1 to 3. It's called arc 1, 3. The arc of a specific direction, meaning the material or good can transport from one node to another direction on that direction. For instance, we can send the material from node 1 to 3, but we cannot send the material from node 2 from 1. We use the notation ij to indicate the arc going from node I to j. In the diagram above, each arrow represents the path with the specific capacity and cost for transportation. The capacity indicates the maximum amount that can be transported along the path. So consider that this path is 2, 4, and while the cost per unit represents the expense associated with each unit of transport. For example, in arrow 2, 4, the flow can range from 0 to 4 because the capacity is 4. And each unit of passing through the dispense costs $2. The symbol infinity here indicates that there is no limit in the capacity of that particular arc. Moreover, the number in the parentheses next to the circle represent the available supply and required demand at each node. In this diagram, node 1 is a starting point with the supply of 20 units, and node 4 and 5 are the destination that require 5 and 15 units respectively, indicated by negative sign. In the minimum cost problem, our objective is to discover the flow pattern incurring the minimum cost. To formulate this problem as a linear programming model, let's consider the following notation. Xij, let's represent the quantity of unit transport from node I to j using arc ij. This is the main variable that we use in this problem. Now let's present the linear programming model for minimum cost flow problem. So equation 1 to 5 represent the flow balance equation in the network. Let's consider the balance equation in node 1 as an example. Equation state this equation. The equation states that the combined flow leaving node I, which is arrow 1, 2, and 1, 3, should be equal to supply available at node I. So you can see that node 1, 2 arrow leave this node. So x1, 2 plus x1, 3 is equal to 20. This is the balance equation for node 1. This ensures that the outgoing flow match the available supply. Similarly, the balance equation at node 2 indicate that the incoming flow to node 2, so we have one incoming flow to node 2 is equal, which is x12 is equal to its outgoing flow from node 2, so is equal to x24, 23, and 25. This ensures that the flow entering and leaving node is properly balanced. The minimum cost problem is the network that has a unique structure that helps determine the solution algorithm. The flow variable denote xij balance equation have coefficient 0, +1, and -1. Additionally, this variable appear precisely in two equations. Once with the equation 1 represent the node where the flow origin, here this is +1 x12, this is for node 1, and the ones with the equation -1 here representing the node where our flow enters. So you can see that the node 2 and the flow from arc 1 to enter to node 2. That's why we have the -1. Based on the above characteristic, the general form of minimum cost problem can be expressed as follows. So another one, we have the capacity for arc. You can see as a constraint at the bottom of the model, and we have the objective function we are going to minimize. So this is the cost for each unit of transport passing each arc. So this is a general form of the minimum cost flow problem. The model shown here represents the general form. However, we can simply simplify this model in the other form that we explain in this presentation. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by filling the contact form in our website, which is www.optimizationcity.com. Thank you so much and goodbye for now.